Enzyme Action. So, step 1, you start with your enzyme, which is a catalyst. Its goal is to speed up a reaction. This is the active site where the substrates match up with the enzyme. Step 2, this is when the substrates come together with the enzyme at the active site.
Step 3. This is where the process hydrolysis occurs. The substrates in the enzyme will be broken apart by a water molecule.
Step 4. The enzyme is almost ready for reuse. The substrates leave the enzyme and are separated. These products are amino acids.
This is a process of competitive inhibition. The inhibitor molecule binds with the active site of the enzyme. The inhibitor prevents the substrate from binding onto the enzyme.
This is a process of non-competitive inhibition. The non-competitive inhibitor binds onto the enzyme and changes its shape. Substrates can bind onto the enzyme but no reaction occurs.
Enzyme action. The substrates bind on active site, forming the enzyme substrate complex. The binding of the substrate breaks and products are released. The enzymes are free to bind with other substrates.
Coenzymes are inorganic or organic chemicals that help increase the speed of a reaction. Protein is inactive until a cofactor is binded. Once the cofactor binds them, the protein is activated.
Glucose molecules and enzymes. Glucose is created when two maltose molecules are bonded together at the active site of the enzyme. The maltose enzyme breaks the bond and the two glucose molecules are released as products.
The effect of concentration, temperature, and pH on enzyme action.
The effect of pH on enzyme action. As the pH increases, so does the enzyme action until it reaches its optimum pH level.
The effect of temperature on enzyme action. As the temperature increases, so does the enzyme activity until it reaches its optimum temperature.
The effect of concentration on enzyme action. When the substrate reaches its point of saturation or concentration, the reaction is no longer effected.
Allosteric inhibitor. The inhibitor molecule binds with the allosteric site of the enzyme and changes the shape of the active site. The original substrate can no longer bind with the new shape created, and the allosteric inhibitor becomes the new product.
Metabolic pathway. You start with your substrate, which binds onto each enzyme and changes its form. Once it reaches the last enzyme of the pathway, new products are formed. The new products are completely different from the original substrate.